Hi everyone and welcome into this new video. In this video we continue the Active Directory Exploitation series and specifically we talk about SMB, so the SMB protocol. In this video specifically I will showcase 8 different threats associated with the SMB protocol. Now you can use these threats in 2 different ways. From an attacker point of view, of course I will show how to abuse that misconfiguration, how to abuse that technique to gain privileges and exploit an Active Directory instance. From a defensive point of view, you can use the following threats to defend against those threats. Like now that you know the scenario, now that you know how the attack works out, you can better harden your Active Directory instance. This means that even though the focus will be on the offensive side, this will still be useful to people looking for better defending their AD instances. So that's the idea. And of course, while showcasing the different threats, I will use a bunch of different tools, including specifically the following ones. These are used for enumeration and also exploitation, specifically the netexec one, which is the successor of the crackmap exec. So we will see how to play around with this tool, which is very powerful, and the netexec tool will also be used in future videos of the series because it is a very powerful tool. So as always, I hope this video is useful, I hope you get something out of it. If you do, subscribe to the channel, share this video and this channel with like-minded people to help me grow, and enjoy the video. So I want to start with an extremely basic introduction. Here I did not write much because I already talked a lot about SMB in the previous video. So if you have no clue about SMB, go and catch up on the previous video of the series. Now, SMB stands for Server Message Block. It is a network protocol that was developed mainly for file sharing, but also for sharing of printers and things of the sort. So it enables computers on a network to share files, printers, and other resources, and it is used specifically in Active Directory instances. So it is often found in AD deployments. Now, what are the different threats associated with SMB? And while discussing the threats, we will also talk about the different tools. So let's discuss about the first scenario, which is also the first threat. So the first threat is about guest or anonymous access to the SMB shares. So what's the idea? Well, the idea is that sometimes it is possible to properly authenticate to an SMB server even if we don't know any credential whatsoever. So the idea is that typically we would need to find some credential to interact with the SMB, to authenticate with the SMB. Well, this is not always true actually. And the fact that sometimes shares are open to guest accounts or to anonymous logins can be of course really dangerous. So the first thing you should do is you should check for this kind of threat. Now, here there is a difference between guest access and anonymous access, and here I will put a very useful article that describes it. Of course, I will also describe it in the video. So the idea is that, okay, how can we check for this specific threat? And here comes the tool that I mentioned, the SMB Tools. So you can see here I just open a shell on the right, here I can execute my commands, and I just have a bunch of word lists, so no tools installed. So let's start with the smbmap, which is really simple but effective. So the idea is that this is a Python package which we can install with pip. But before installing with pip, we need to create a virtual environment in Python. So here I showcase the exact commands that you need to execute. So first you create the environment with Python 3-mvm. Then you activate the environment in the current shell, and then you install the tool with pip. You do pip3 install smbmap. It's gonna download everything it needs and it's gonna install the tool. Now, after you downloaded the tool, you can access it with the command smbmap, and here you can say, for example, help and things of the sort. So what can you do with this tool? Well, for example, you can try to list out the anonymous share. So in this case, we're simply going to execute the command without giving it any credential. We just give it the IP address with the option -h, and we will see that in this case, the command will not return us anything. Now, does it mean that there are no exposed shared? Actually, this is not the case because other commands will work. However, this one doesn't. I'm not able to establish the reason why, but that's how things are essentially. Maybe it could be something with the way I configure the domain. So a simple anonymous access is done with this. And then, for example, if you want to authenticate with a user instead, we can say if we want to put the password on the command line, which of course is not really a recommended way of authenticating, but if we want, we can put the option -u and -p. So for example, like this, here, notice that I'm enumerating all the shares, but this time I'm properly authenticating with a user. Therefore, I do need credential for this. And if I want to put the password, but with a prompt so that it is not saved in the command line, I can do --prompt, and here I write the password example123 ! And I get the same result. So as you can see here, for example, here we have a bunch of different shares. We have these shared files in which we have read and write access, and then we have the test2 in which we have the read and write access. For the test, we just have no access. And then we have the user share, the sysvol, the IPC, the C, and the admin. And notice that these three, we have no access, and they end with the $. The IPC, we only have read-only access. This other, we have no access. And also, here the test, we have no access. So that's the idea. So typically admin, C, IPC, and sysvol are used in the context of Windows and of Active Directory, specifically the sysvol. So this is typically what you would find, and also the netlogon. So this is typically what you'll find when you enumerate the share of an Active Directory. Of course, the custom share that are specific to the domain will appear with custom names, like shared files, test2, and things of the sort. So of course, let's say that I want to list out all the files in a given share. So I can use this command smbmap, then I put the domain example.lab. Sometimes it's not needed, sometimes it is. And then I put -r with the name of the share. So we execute this other command. And here, notice this what we get. So this is the command smbmap examp and then -r share files. And here we get the files test.txt. So this file is listed here and it says, look, there's actually a file called test.txt, which is pretty cool. So actually let's open like this because it's gonna be, I can zoom in better like this, perfect. So this is to list out the files in a given share with smbmap. We can also do other stuff. For example, we can read the operating system version with -v, and here it says, look, this is running Windows Server 2022. So this is very useful enumeration information. We can check, for example, if the signing of messages is enabled, and in this case, it is disabled, and this can be used for attacks that we will see at the end of this video. And essentially for smbmap, I don't use it too much, but this is like a quick tool that you can use just to get this information. Then we find smbclient. So with smbclient, essentially you do -l, then you put the IP address of the server, and then you put -u with your username. In this case, it's gonna prompt me for the password. It's gonna say, look, put your password. I put the password that I used to authenticate with the domain, and here I have the list of shares. Instead, I can also put the password in the command line with this other command. So here, remember that it's like domain / this /, then username, then this %, percentage, and then the password itself. But as always, do not use these commands from the command line. Always use the commands that ask for a prompt, that ask for the password through a prompt, because typically files like commands that you write on the command line like this can be saved in history files, in logs. So especially if you have confidential information, be sure to not put it in the terminal too much because it can be dangerous. Of course, in this case, it's just a dummy password, so we don't really care. Now, this is to enumerate, but if you want to access the share, what smbclient provides, which is cooler, I would say, than a simple smbmap, is actually an access to the file system exposed by the share. So look at this. It's the same command as before, but now we put this -share file, we remove the -l. So we don't want to list out, we just want to connect to the share, and we want to connect to the share files. And once we do this, we get a prompt, and now this is like a typical file system prompt of a console. However, we are authenticated with the share, so now we can access the remote files. So we can do ls, we can do cd to change directories, and we can even download and upload files. So we can do get.txt to download the file from the remote server, so we can open it and it says, this is an example file shared using SMB. I can modify the file. Let's modify it from Linux. And then I updated the file. I can even put it back. So I can put it back into place. And if I log into the domain controller, for example, I will see the file updated. So here I have the file, the shared file. And look at this. This has been modified from Linux. This also means that with SMB, of course, you can share files between Windows and Linux, which is very useful in certain networks. So that's the smbmap and smbclient are very simple tools. They are not too sophisticated. The tool that I actually recommend, the main tool that we'll see, is called netexec. Now, this tool is the successor of the famous crack map exec. It is an extremely versatile tool. We can we can use it to play around with SMB, but we can also use it to play around with a lot of different protocols. So how do you install netexec? It depends on your distribution of choice. For example, here I'm using Arch Linux, so it is a simple yi-s netexec. But of course, there is documentation with respect to the different platforms. In this video, I don't want to show the installation process because I want to focus on the actual commands and on how to use it. The installation process is a technical problem that can be solved maybe in another video outside of the series. So for example, let's go back to the threat that we discussed. So guest or anonymous access. We show that with smbmap, for some reason, it actually did not work out, because if we did smbmap and we just put nothing, this it said no fun for you. It said, look, there are no shares that were anonymously shared with you. Actually, if we use netexec and we can access netexec with the command nxc, so this one, nxc, and it says, look, we have all these different protocols, VNC, WinRM, WinMI, NFS, SMB, FSC, MySQL, so like a lot of different protocols. Of course, this video is about SMB, so we focus on SMB. So this is the basic enumeration when we're able to authenticate, so with credential. So typical -u, typical -p, and --shares. And here we put the SMB. So we can specify, look, I want netexec specialized for SMB, and here we put the IP address of the domain controller. So this simple command, we execute it, and we wait a bit and we get our answer. So this is a much better output, first of all, because it tells us like, look, SMB version 1 is actually available, which is a security danger, is a security threat. The signing is disabled, another security threat, and here are the shares with the various permissions. And here it says the green check means that I've properly authenticated to the SMB server. Here I get the IP address and the port and the domain name of the server, which in this case is the domain controller DC01. Perfect. Now, let's say that I want to check for null session. So null session means anonymous session. I can do this as follows. I can do this by just putting -u and -p with empty values. And then I do --shares to list out the shares. If I do it like this with netexec, notice that now I do get some output. It means that I am properly authenticated to the domain. However, notice that I did not put any authenticating information whatsoever. How does it work under the hood? Well, under the hood, this Active Directory instance was configured to allow anonymous login. And to configure this instance to allow anonymous login, you have to change a bunch of different policies, which we will see in a bit. But the idea essentially is that once this is enabled, everyone, even people without authentication, can properly enumerate the shares, even without any sort of credential. So this is the first thing you should do. Check for anonymous session, which is also called null session. Another thing which is very related to anonymous login, anonymous access, is called guest account access. So in this case, it's a little bit weird, as always with Microsoft, because the idea is that here you just put some account that does not exist. So you put a username that actually does not exist in the domain. And if you do that with an empty password, then you test for guest access. So you do this, for example, and notice that now, look at this. So here I've authenticated with the guest. So netexec tells me, in parentheses, look, you are guest authenticated. Before, it did not tell me anything, so I had no user here. In this case, I am authenticated with a guest, and I have this. Essentially, I believe that I see the same shares. I see the same shares because they have the same permission. However, they work at the level of configuration, they work in slightly different ways. And so the idea for this scenario and for this threat is pretty simple. Be sure to try out guest access with an account that does not exist and null or anonymous session. It's the same thing with empty credential. If you get access to that, well, you might be able to do stuff. For example, in this case, if I use the -- users of SMB, I'm also able to enumerate the users of the domain in this case, because the domain is configured to allow this thing. So I see that there is a user Leo, a user test, and the typical users like the Kerberos one, the administrator, and the guest. So that's really powerful. Now, if you're interested in how I configure my Active Directory domain to allow this kind of thing, well, the first thing, of course, you want to share a folder. You want to share a folder, and here in this folder, you want to share it with essentially these accounts. So with everyone, with guest, and with anonymous logon. Here you can choose and pick your kind of permissions. And then you go into essentially the group policy management tool, which I show how to get there in one of the previous videos with gpmc.mc. And here you go into essentially, so the thing is, you go into computer configuration, then policies, then Windows settings, then security settings, then local policies, and then security options. And here you have to disable a bunch of different options, specifically these ones. Network access do not allow anonymous enumeration of some accounts and shares. So there's one for some accounts specifically, and there's ones for some accounts and share. So you want to disable this option. You want to enable that everyone permissions also apply to anonymous users. Here you want to essentially put the shares that can be accessed anonymously into the shared files, although I'm not sure if it's strictly needed, to be honest, probably not. This one is probably not needed. And another thing that I did is, if you go into the Active Directory users and computers here, into the built-in, here you can see this pre-Windows 2000 compatible access. Well, you want to add to this built-in group, the anonymous logon. So you want to put anonymous logon as member of this group. And in my setup, when I did this, essentially I was able to make the vulnerability work. So I will also put some link in the description that showcase a different configuration that might be needed for to expose this thing. Or you can also get like a vulnerable instance from ActiveBox or TryAcme. I will put some link into the description that you can play around with this vulnerability. I mean, it's really simple, it's not too complex. You just execute the command. If you get something, then it means that some shares are exposed. And so this is the first threat. So we get access to a share. Now, in the second threat, I want to showcase what happens if you get access to an administrative share. So to one of those shares, for example, the admin, the IPC, like shares that typically we do not have access over. So let's think about this. If it is possible to access administrative shares such as admin C, IPC, then it might be possible to obtain remote code execution. So here we're going from a misconfiguration of SMB to full remote code execution, and therefore we get access to the machine itself. Now consider with smbmap, so let's go back to a simple smbmap with the credential of the administrator. So notice it says, look, we're admin, we have read-write to everything essentially, so that's very good. Now to execute commands using smbmap, we can simply add this -x option with the command itself. So very, very simple. Look at this, it's going to take a while. but we get our command xdump/administrator. Of course, you might be execute more stuff, not only whoami, like for example a dir to get all the files of the current directory where the process is running. And we can see that this is the directory of c/, the C share essentially. And of course, in these commands, you can put any sort of reverse shell payload, as I showed multiple times in the Windows exploitation series, in the Windows privilege escalation series. So like, if you are interested in how to do that, go and look out the videos of reverse shell in that series. So once you obtain, of course, RCE, there are many things that you can do. And if you want to execute the same thing but with netexec, you just call the command, you put the SMB, the usual stuff, and then you put a -x with the name of your command, as was the case for smbmap. Now, with netexec, we can actually specify if we want to execute a cmd command or a PowerShell command. So this is of course a lot of privileges because this user is running as a domain admin, clearly. We can also do the same thing but with the capital X, and in this case we're gonna get a PowerShell command. So here of course the output is the same, but we can mix and match PowerShell and CMD in a much easier way. And so this is it for the second threat associated with the SMB, which is the possibility of escalating privileges to obtain directly remote code execution. Remember, this requires having access to administrative shares. But as always, if you have access to this thing, then you should try out this way to obtain RC, because it's a really easy way after all. So the first one is about anonymous or guest access. The second one is about RC via root shares. The third one is about brute forcing, because of course, anytime we have to deal with an authentication, we can always try to brute force it. So to showcase some brute forcing, I will showcase the tool Legba, which was developed by EvilSocket. It's a very cool tool that I suggest you to learn. So there is a Docker, by the way, so it's a really simple thing. There is a Docker we can run to just run out the tool. I also showcase the tool in the web exploitation series. So how does this command work? Well, we say the entry point is bin bash, so when we run the tool, we just obtain a shell within the Docker container environment. Then we share a volume with the Docker, and this thing is gonna be the word list. So it's just gonna be a list of like attempts, like users and passwords. Then we put the -- network host so that we share our network interface with the Docker, because in this case, the domain controller is on the network interface that is managed by Camo. So I just want to connect the Docker network interface with the Camo network interface. So this is a simple way to do it. And then this -it to make it interactive. And here I put the identifier for the Docker container in the registry and the version latest. So now I am inside the Docker because I just run this command. Of course, depending on how you configure your environment, you might need to put the sudo command before everything else. If you can only run Docker as sudo, but whatever. So once we have Legba, how do we use it? Well, it's a similar concept of netexec. First, we specify the protocol, because Legba works with multiple protocols. So we say Legba SMB, we put the workgroup, which is xdump.lab. We put a share that we will try to access. We put the username, and then we put the word list for the password. And we put the IP target for the server that exposes the SMB instance. So it's a little bit verbose, but it's a very simple command that contains everything that is needed. So for example, in this case, let's go to data, and notice that here I have this word list of password. I mean, there are not really that many, and they contain the password of the administrator. You can imagine having a really long list of passwords, for example, the typical famous rockq.txt, and stuff like that. So whatever word list you have, this is how you use it. So actually, before running it, here I have to change the path, because here I'm just gonna say, look, take the password.txt from the current directory. So from the current directory, I launched this, and of course it found the administrator password, which is password123!! So very simple, of course. It's not too much, but it's really fast, the tool. So I suggest you to use it even with more tries, essentially. And you can do the same for a different user. For example, for the user Leo, for the share files SMB share. So you can try this. So notice what happens in this case. Now notice that for the user Leo, it gave us multiple results. And this is because the guest access is actually enabled within the SMB. If we remove the guest access, this would not happen, but since it is enabled, this actually happens. The behavior was different with respect to this earlier attempt, because in this earlier attempt, we tried to brute force a share that was not accessible from the guest user. So in that case, it failed. In this case, we have some noise that is introduced by the presence of the guest account. Anyways, if you do not have the guest account, this should be straightforward, and if it finds something, it is typically a true positive. Sometimes there is a chance for false positives when you have a guest account enabled. And so this covers the third threat associated with SMB, which is a typical brute forcing attack. Now, another attack which is close to brute forcing but is a bit different is called password spraying. So what's the idea? Well, the idea is that we can use netexec to perform so-called password spraying. And the idea of password spraying is to use a limited set of passwords to try and authenticate with a large set of accounts. So in brute forcing, typically, we have a fixed set of user, so like for example user 1, and on this user we try many different passwords. We try a big list of passwords, like hundreds of thousands, even millions of passwords over a single account. In password spraying, we do the opposite. So we fix a very limited number of passwords and we spray them over a large amount of users. Basically, the idea is that since passwords are common in the way that people use them, sometimes you have multiple users which use the same password or slight variations over the same password. So having this ability is often very, very powerful to know. For example, in OSCP exams, in this kind of certification exams, they make it easy to understand and to authenticate with different users. So one of the techniques they use is that, okay, maybe they apply different users with the same password. So once you obtain the password from a given user, you can try to authenticate also with other users. So it is always something that you should try if you need more authentication, if you need to access with more users, essentially. So we can exit from the Docker, so very simple setup. With respect to the tool we use to do this attack, I believe also legback can be used for password spraying. However, let's just see netexec to make it simple. So we say netexec smb, the IP address of the domain controller, the user that we want to spray passwords to the user, and the password that we want to spray. So this is like a word list of password. For example, notice here, I have this word list, very, very simple. I do this password spraying here down below, and let's see what happens. Notice that in this case, it told me correctly, look, the xstamp123 works, but the others do not. So we found essentially the correct password among the different tries that we had. And of course, if we put administrator here, and we spray the same password to a different account, we're going to obtain the administrator, so the password 123, not xstamp anymore. And notice here it says pwned. Why does it print this extra text? Because it realizes that administrator has root access to the shares. So it has access to administrative shares, which the user Leo, the basic user, does not have. So netexec helps us in understanding if an account is interesting, essentially. And of course, the really cool thing about netexec is that in this example, I'm showcasing just a single IP and a single username. But actually here you can put multiple IPs, or you can even put a list of IPs in a text file and a list of usernames. And so for example, let's say that I have a list of users and a list of passwords. I can do this command, but this time I'm gonna put users.txt. And if we execute this command, we're gonna get, so it's gonna stop at the first success with the guest account. Now, if you want to actually try all the possibilities, we add this flag called -- continue unsuccess. We just execute that, and it's just gonna keep going. And look, it found guest, whatever. Then it found Leo, and also it found administrator. So with a simple command, we tried a lot of credential. And here we can also do this test on more IPs. So not only on this one, .30, we can go into the workstation, into the Windows 10, which is adjoined to the domain. We can copy the IP and we can put it right here. And we can do the same check on these two different machines if we have like a big attack surface, essentially. So that's the idea. Of course, in this case, it's not going to find anything because the server is not exposed by the workstation, but only by the domain controller. But we can even put it into a ip.txt. So the idea here would be I execute these two, I put these two IPs here, like this. And then here I say ip.txt. So let's delete this and let's just put ip.txt. So this is like the final form of netexec, which is extremely powerful when you have a big attack surface. So this one I'm actually gonna copy. I'm gonna put it into the notes. This one, like this. So very, very powerful. So this is password spraying. Now continuing to the next threat. So the fifth threat, SMB v1 EternalBlue CV 2017-0144. Now older system running vulnerable version of SMB can of course be vulnerable to known exploits. Now one of the most historical one of course was EternalBlue. Now EternalBlue has a rich history, also that in the way that it was leaked by an external group. So it's really fascinating. However, in this video I'm gonna be more technical about it. So essentially this exploit, so this vulnerability, which also has an exploit called EternalBlue, is also known as CV 2017-0144 or the Microsoft identifier MS17010. So to try out this thing, you can download the Blue machine from TryAcme, or you can do the legacy machine from ActiveBox. So here I give you two options. So the idea is that, okay, let's say that here I just downloaded the OVA and I've imported into my machine. I don't know the credential of this user. So how can we exploit this? Well, first of all, how can we get the IP address of this machine? Well, we can do a dynamic scan with nmap with the flag -sp on the subnet of interest. So in this case, it will be this one, because this one is a subnet that I share with Camo. So I'm just gonna like iterate, actually it's this one, it's supposed to be this one because I don't care about the .0. So I'm just gonna iterate here and it finished quickly. So here essentially we get 3 matches. We get the .1, we get the .30, and we get this other. So .30 is the domain controller. .1 is the router within the Camo network thingy, so whatever. So it means that probably this is gonna be the Windows 7. And to make sure, of course, we do another scan, and we do a scan specifically. So here we do a scan specifically on this IP, and specifically on port 445. So why on port 445? Because that is the port that is exposed by SMB. And after the scan, so here is the command that I use for the scan, what we get is, look, the port is open, it is a Windows 7 professional, and essentially here we have that workgroup jump PC, so we have information about the machine itself. So how do we test for something known like EternalBlue? So here I open my notes. So we can use specific scripts. So we can use the SMB vuln MS1701 script, so this one. So we can do with this, and look, immediately it said, look, this is actually vulnerable. It is, of course, risk factor high because this allows an attacker to obtain remote code execution. This vulnerability was actually exploited by the ransomware WannaCry. So there is, as I said, a lot of history about this exploit. Maybe I can explore in a future video. This is like well-known stuff in the community, but it still can be interesting to like dig up and learn. So we can use this nmap script, so very powerful scripting facility of nmap. We can also use MF console, so the Metasploit console, the Metasploit framework. I don't use it that much, but sometimes it's useful, especially for these well-known vulnerabilities where the exploit code is pretty well robust and reliable. So how do we use that? Well, it's really simple, once again with Docker. So when it comes to this complex software that maybe have dependencies that require specific environment, I always suggest Docker. So here probably the only thing that I did not show Docker for was netexec. But to be honest, you should make a simple Docker container for netexec, and I'm sure that other exist already. because with Docker, you are sure that in times of need, you can just run it and it's going to work, unless you really fuck up your system, but this typically does not happen. So you do a Docker pull of the framework itself, and then you run it with the typical -- network host, as we said. So we run it here. So of course now it requires privileges. So after I run the Docker, here I'm just going to do docker exec, and then I'm going to spawn up a bash shell within the Docker. So once again with sudo, I always forget. So now we are within the Docker. So we can do mf console to start up. So actually I have to execute this command /mf console. So here I say start metasploit. So it's gonna say some like deprecation notices for the future, but we don't care. So at this point, we should have the framework ready. So here we wait a bit maybe. So once we have our shell, what can we do with the shell? Well, if you never use Metasploit, essentially the idea is that it works in modules, and each module provides a functionality. There are scanner modules to understand if a system is vulnerable, and exploit modules to actually attack them. So first we can run the scanner. So we use this auxiliary scanner SMB, so this specific module. Now each module has a set of options which we can show with show options. For example, in this case, one of the most typical options that you have to set up is the rhost option, which is essentially what is the IP address that you need to target. So in this case, we put the IP address of the machine, and then we do run. So we do a simple run, and it says host is likely vulnerable to the EternalBlue attack. So this is a simple scanning. Then we can do the exploit itself. So use exploit. So once again, we put the rhost. Let's do show options, because in this case, I also need to put something for the lhost here, because essentially the idea is that this exploit will trigger a reverse shell to our machine. These exploits are very noisy, but in this case, there's no antivirus, so it's fine. And to spawn a reverse shell, we actually need to set up our local IP address. Now this one is not gonna work because this address is not reachable by the Windows 11 machine. To be reachable, you need to be in the 122 network subspace. So the idea is that you do set lhost, and then you put 122.1. So this is the IP address that the Windows 7 machine can actually reach. The port 444 is good. This is good. And then we can do run. So here we can do run, and here we can see that we are actually like exploiting the vulnerability. And in a bit, we're going to get our shell, and we're going to get us remote code execution. So it's going to set the stage, and now we have a meterpreter shell. So here we can say the various commands. These are executed on the machine, of course. So actually, let's do C // So here I am in the user. Here I have the flag essentially, for example. Flag access the machine. So this is like a simple CTF with one exploit to go. And so this covers the fifth threat, which is the presence of known vulnerabilities in the SMB stack of the server. If there are known vulnerabilities with known and public exploits that are not too easy to execute, this is of course dangerous, and you should look to use them to attack a system, or vice versa, you should look to upgrade and update your system to not be attacked by such like simple exploits or exploits that can be obtained easily in the internet. So that's the fifth threat. So now we can start to analyze the sixth threat, which is the Net-NTLM capture attack. Now, when a Windows client authenticates to an SMB server, the NTLM hash of the client is sent to the server for authentication purposes. And here there is a very beautiful article that describes the difference between LM, NTLM, Net-NTLM hashes. And in the article, you can find the following two descriptions for how the Net-NTLM v1 and the Net-NTLM v2 are computed. So these are two different protocols that can be used during Net-NTLM authentication, essentially. And during this computation here, you can see that at some point, the hash of the user actually comes into the picture, the NT hash of the user. So the hash is not sent directly, but it is like processed accordingly to the protocol, and it is sent to the server for authentication purposes. Now, the idea is that it is possible to obtain the Net-NTLM hash of the user by forcing a client to authenticate with a fake SMB server. And for example, possible scenarios are you do a phishing attack to a real user. For example, to a real user you say, access this SMB server because there are some new documents for work or things of the sort. You try to phish the user into authenticated with a fake SMB server, or let's say that you actually obtain code execution over a system, but you're not able to obtain the password over that user. So the idea is that by forcing an authentication with an outside SMB server that you control, you can leak out the Net-NTLM hash. Once you have this hash, you can try to crack it to obtain the user password. So this is a practical attack that you can do, because the idea is that if you are a client here, so this is like a client Windows, it's authenticated, so it's currently authenticated. Here is a fake SMB server. You fake the connection, you force the connection. Of course, this server is fake, it's not gonna reply correctly, but it's gonna get these two different hashes depending on the protocol. And from those, you can try to crack the password of the user. So let's see a practical way on how to do it. Very simple. So once again, we have our Python virtual environment. Here we can exit from the shell. We don't care about that actually. So we have our Python virtual environment. We just have to install in-packet and net ifaces. So we do this to install, here also pip3. So that's good. And then we clone Responder, which is a project that essentially allows to create a fake SMB server. So we go into the Responder and we launch it with this command, a simple command. We need sudo privileges and we need to specify the network interface. So this specifically is the network interface that we share with the victim. So if our computer is connected to multiple networks, we need to put the interface that is shared between the victim machine. For example, in this case, I will put this interface, which is the var_br0. It's the QEMU interface. And so here I can launch the command. So I can do sudo python3 responder -i verb0. And here it is not able to run the DNS server, but we don't care about that. It is able to run the SMB server. So that's good. Now, let's check the notes. Then, from the victim machine, we simply have to force a connection. We can do it with a simple dir command. So let's do this dir command. So let's go into the spicy viewer 3, I believe. So on the left, I have my responder server up and running that is running a fake SMB server. On the right, I have a workstation that I compromised. From the compromised workstation, I'm gonna authenticate to the fake SMB server. And this can be done with a simple dir command. It's just important that here I put the IP address of my fake SMB server. And once I establish this connection, the machine is gonna send the Net-NTLM hash, which is gonna leak, because now the attacker can see it. So I send it, I connect, and notice here what do I get? I get the Net-NTLM v2 hash of the administrator. Now what can I do with this? Well, I can take this and I can crack it in the hopes of getting the password of the administrator. So basically that's the capture attack. So that's the Net-NTLM capture attack. And once I have this hash, I can try to crack it with, for example, either John or Hashcat. I can both crack the Net-NTLM v1 and v2. So with the v1, the format is Net-NTLM. With the v2 is Net-NTLM v2 with a given word list. And with Hashcat, the codes are 5500, 5600. So that's the idea. And this was also discussed, by the way, in the Windows previous series when I discussed about Windows hashes. So a way to obtain hashes is by capturing them with a responder. So let's go with the next threat, the pass the hash attack or PTH. So let's say that we managed to obtain the NTLM hash of one of our users. Now it is possible to give such hash to SMB in order to authenticate as the user via so-called pass the hash attack. Essentially, with the hash we can authenticate as the user even if you are not able to crack the hash to obtain the plaintext password. Now, one thing that is important to mention is that to perform this attack, we cannot use the Net-NTLM hash itself. So the one we obtained from responder in the previous scenario. So we cannot use this directly because we actually need the underlying hash, which is the Net-NTLM hash. So the Net-NTLM hash, we can see it's sort of like we start from the password of the user. But of course, this one is not stored directly. What is stored is an NTLM hash. And then when we send it into the network, we actually send the Net-NTLM. So we cannot use this, we need to use the hash. However, it is still a critical attack to mention because sometimes we cannot crack these hashes. Sometimes we obtain access to these hashes with tools such as Mimikatz, but we are still not able to crack them. So the idea is that even though we cannot crack them, we can actually use them. Because the idea is that if we give to these services like SMB the hash of a user, we can still obtain authentication as that user and we can still execute stuff with that user. So for example, this is the hash of the administrator user and we can use it like a normal password. It's just that instead of the -p, we have to specify the -h option. But other than that, it's the same. So here I can stop the responder and here I can put this command and it's gonna say that I'm properly authenticated. So look at this, I'm authenticated. Here I can list out the shares and I can even execute commands with this. So these are the shares of the admin. Look at this. And this is the command to execute commands. So it's the -x, which executes the who am I. So in this sense, it's gonna say xstamp administrator. Of course, I can also say, I don't know, dir, just to, a different command to list out the contents of the file. I can read out the files and things of the sort. Look at this is the directory. So that's the idea. And of course, what we said about password spraying also applies to the NTLM hash. We can also spray the hashes to different users. So let's say that we find this hash, but we don't know the user it belongs to. No worries. We can just spray it along with netexec. And for example, with this, we are spraying this particular hash on a word list of user, and we say continue on success so that it doesn't stop at the guest. And here we see essentially that we found whatever the guest is always true, and then we found that this hash belongs to the administrator actually, because here we do not have guest, we have pwned, which means that this is actually the credential for the administrator. So at this point, we can discuss the final scenario. So the pass the hash attack can only be done with the NTLM hashes of the user. But what if we only have the Net-NTLM that we capture with responder? Well, if we cannot crack the hash, another idea is actually to relay it. So the idea is that we can relay the hash to a proper SMB server, and then we can establish a session as that user. Sort of like we fish the user into a man in the middle. You can think of relaying as in man in the middling SMB, so man in the middle in the SMB protocol. So this attack can only be done if the server does not require signing. And notice that from the previous commands here, if I just do this, for example, here I get that here signing is false because it is disabled. So if this is disabled, we can actually perform this relay attack. And we can also check this within the domain controller in a PowerShell to check if it is enabled or disabled. In this case, it's gonna do enable protocol security requires security signature false. So the signature is not required and therefore we do not have signing. And we can also disable it from the group policy object. So from gpedit.msc, here we go into this option essentially. It's network, Microsoft Network Client, digital design communication. So that's the idea. And we can also disable it from PowerShell. So set configuration requires security signature false. We can actually do client and server configuration. So the SMB relay attack works in 4 steps. So in the first step, we are intercepting an authentication attempt. So here we have our client, which is our victim. Here we have our malicious server. Let's say that this is the client and this is the official server. So the client would just typically authenticate to the server. However, in this case, we put ourselves in the middle. So we need to intercept this thing and we have to make it pass through us essentially. So we capture the Net-NTLM challenge response, we relay it to the target SMB, and then once we have this, we have established essentially a connection and we can obtain unauthorized access. Once the server gives us the access token, we can use it for our own purposes essentially. So that's the idea. Okay, so in practice, how do we do it? Well, it's actually simpler than it seems. And here everything is documented because that's the idea of this channel. So the first step is, okay, let's obtain a list of the servers that do not enforce signing and therefore can be relayed. So they are vulnerable to this kind of attack. So very simple, we put the gen relay list out.txt. In this out.txt list, we have all the IPs that can be targeted with this relay attack. And so this is to get the list out. Now to start the server that actually will relay the hash, we use this tool called NTLM Relay X, which is part of InPacket. So once you install InPacket, you should have access to this tool. And we use this tool with the following options. So we disable the HTTP server because we do not need it. We enable the support for SMB. And most importantly, we specify the target to which we want to relay the credential. So here we are saying, when I get something from the official client that we are phishing, I want to send it to this server. So this T is the target. It's going to be the server that we relay the credential to. And then we put -socks to open a SOCKS proxy. And once everything is done, we will be able to use that SOCKS proxy to relay messages to the server authenticated as the original user, as the victim user. So that's essentially the idea. So let's open our shell, spicy3. So let's open here another shell here, and let's use this command. So here I've started the proxy relay. Perfect. Here I'm going to do this other command as before, essentially in the Windows workstation. So notice what happened. So it says authenticating against SMB XDump administrator succeed, adding XDump administrator to active SOCKS. So at this point, it actually created an authenticated session because it relayed the authentication attempt from the workstation, and now we have a proper authentication. Indeed, if we write here SOCKS, notice that we get this admin status true, XDump administrator, so we have a current session as administrator, and to actually execute commands over the SOCKS proxy, what's the idea? Well, if we check the open ports, in this case, we're going to see that an open port is this 1080, so this is the default port that is used by the NTLM Relay X for the SOCKS proxy, and so now we have this SOCKS proxy open. How do we use it? Well, we can use proxy chains. So you can download proxy chains. Essentially, the idea is that this tool is going to take any command that you put and it's going to proxy that command through a defined SOCKS proxy. How do we define the SOCKS proxy? Well, we can go into the etc proxy chains config. So cat etc proxychain.conf, and at the end of this file, you will see this SOCKS for this kind of attack, you want to put 127.0.0.1.1080 because this is the port that the NTLM Relay X has created. So to recap, essentially what happened is that initially we had the client that was trying to connect to the server and we had our attacker. Now we relayed the authentication attempt through the attacker, through the relay, which relayed to the session, to the server. The server was like, okay, look, this seems good. I give you a session. And now here, from the attacker box here, I have a SOCKS proxy connection to the server. And this SOCKS proxy exit from the localhost 1080. So if I want to execute something using the client session over this service, I can do the command, but I have to prefix the command with proxy chains. For example, here we have three different examples. Lookup SID. So we're gonna do, here the key is this -no-pass, because we don't need a password because we already authenticated as XDump administrator at the domain controller. So we execute this command. I believe that looks, no, I need of course the InPacket, so I need to log in into the environment, the virtual environment. And look at this, it actually dumped all the different seeds for the users. Another thing that I can do, for example, is I can use the secretsdump.py to leak stuff. Although I'm not sure how well it works because at some point it crashes. So maybe that's something to be looked at better. And then I also have the smbexec to actually execute stuff. So I do smbexec and look at that. Now I have a shell. So I have a shell in the system. I can do whatever I want at this point. So let's see like this. You can cd under smbexec useful path. Okay, so what about see like this? Dir like this. Again, who am I priv? I can execute commands with this session essentially. And so discover the final threat, which is, I guess, one of the most sophisticated attacks in terms of theory. But as you can see, in practice, it's not that hard. You just have to make sure that the server does not enable signing, of course, because otherwise this cannot be done. It is essentially a man in the middle. And then you activate the relay, and then you force a client to connect to your relay. And this creates a SOX proxy that you can then use to execute different commands. And so basically this is the idea. Of course, in this video I rush a little bit the usage of proxy chains. In the future I will go more slow about it, but this video is already long as it is. So essentially we are done. So this is it for this video. We analyze 8 different threats associated with SMB, all of which can be dangerous and can be used to exploit an SMB instance. So be careful about this. I hope it was fun. I hope it was enjoyable. If you have any feedback, leave it in the comments and see ya to the next video.